Welcome back, day 4 of Alvin of Core 2016, Security through Obscurity. Finally, you come across an information kiosk with a list of rooms. Of course, the list is encrypted and full of decoy data, but the instructions to decoy the list are barely hidden nearby. Better remove the decoy data first. Each room consists of an encrypted name, lowercase letter, separated by dashes, followed by a dash, a separator ID, and a checksum in square brackets. The room is real, not a decoy, if the checksum is the five most common letters in the encrypted name, in order, with ties broken by alphabetization. Okay, so we have this, and this is a real room, because the most common letters are A and B, and then a tie between X, Y, Z, which are listed alphabetically. Then we have a few more examples. This one is real because although the letters are all tied, one of each, the first 5 are listed alphabetically. Not a real room is a real room. Same reasons as above, totally real room is not real. Of the real rooms from the list above, the sum of their sector IDs is 1514. What is the sum of sector IDs of the real rooms? The sector ID is this thing in the back. So we can copy this into our input, all of those. And based on the example, we can check if we can hit the correct checksum of the sector IDs of 1514. No, the sum of the sector IDs. The checksum is this. Okay, let's get the parsing done. For each line, we can split it by this. A first one. This will get us the first part of this and before the bracket. This is the checksum, and then we should remove all the digits from the rest. A0 dot filter it dot is digit filter not is digit, and then we just map it. Well, we just have a list of I have a list of cars, right? List of cars. For each car, we can count how many there are. And this can be mapped. C2 sorted by second to map. No, let's leave it as a list of pairs. Jars by frequency. And so each character, how often they appear. So we'll look what comes out of here. I'll print the line and the characters by frequency. Map is still sorted. So we sort it by the amount, and we need descending, and we don't care about filter, it's not digits, and it is not minus. Don't care about the minuses or dash. So we have 3, 5, 1, 1, 1, and then we want to sort this map further. Can I sort here by 2 things or something? First. No. Sorted with something like this. Pair of char in. Okay, so it works like this. Sorted with, compare by descending pair of char int, so we have pairs of chars in int. First descending by it.second, which is the count, and then ascending by the first, which is just xyz. Let's see if that works. Yeah, now we have A, B, X, Y, Z. Then we need to get the first 5. Take 5. Oh. Ah, yeah, wait. If we just keep it as a list, should be able to take 5. And then map the key or the first character. And then we need to we can actually join to string. First 5. Yeah, and they need to equal the, if these guys equal the checksum, then we want to create a result which is numbers equals a0.filter is digit dot. So this is a string now? Yeah, then I can do just do to int. Or is it a sector ID or something? Let's use this, and then we print result, and we want to have 15, 14. Yeah, okay. Let's get the large example. See what we get. This. And that's correct. Part 2. With all the decoy data out of the way, it's time to decrypt this list and get moving. The room names are encrypted by a state-of-the-art shift cipher. Shift cipher, Caesar cipher. In cryptography, also known as Caesar cipher, is one of the simplest most well-known encryption techniques. Substitution cipher. which is nearly unbreakable without the right software. However, the information kiosk designers at Easter Bunny HQ were not expecting to deal with a master cryptographer like yourself. To decrypt a room name, rotate each letter forward through the alphabet A number of times equal to the room's sector ID. A becomes B, B becomes C, and Z becomes A. Dashes become spaces. And then we can decrypt the name. What is the sector ID of the room where North Pole objects are stored? Okay, so now we're interested in the sector ID of a specific room after we rotated some words. So let's rotate this word. What is this? Then we just filter the digits. Maybe we want to leave the spaces. Split. For each part, we can actually, let's just rotate it. For each character, is be rotated by the, okay, we need the last part first. Okay, let's just get this splitted. This, and then split it dot last. Dot to int is the checksum. Is it checksum? Not really. It's a number n or something. And then we don't need the last one then. And then we can rotate each letter, which what do we have? Code, print, let's print this, let's see what we get. Then based on the codes we can easily, okay, Z is 122. Z is this. Do we have A? We don't have A in here. Let's do A. This. So we just do C.code minus 97. Then A is 0. Then we take that and modulo 26. No, then we take that and plus n. Then we modulo 26. And then we plus 97. And then we have to do the opposite of code, which is, I'm not sure, 2-digit char. No. Two car. Hello. The resulting car code is equal to this value. Let's see what happens. Very encrypted name. Perfect. Okay, we have more like something like this. Join to string. Let's print this, and then also we need to remove this A. Very encrypted name. Nice. Now we can encrypt a word. Now we go and encrypt all the words. For each word. Could also map this maybe to I wonder if we should just be checking valid words. Doesn't really say. North Pole where objects are stored. North Pole object storage. Okay. What's the word for it though? Let's print the words. This one. So we just want this number, right? And that's it for day 4. So we first had to sum all the sector IDs for real rooms. Let's have a look. We sum up the result in this variable, go through each row, split the line at square bracket opening, get the second part after the square bracket until before the square bracket closing, which is the checksum, which is this. Then sector ID, we filter all the characters that are digits, and this is these three, and pass them to int. Then we have an ID, then we get the characters, which is the non-digits, and ignore the dashes, get a list of characters, get all the distinct characters. For each distinct character, we map distinct character to how many of those are there in the original list of characters. We sort this map descending by the second, which is the count, and ascending by the first, which is the character. So X, Y, Z is in this order if they have the same count. If the first 5 characters, which we map here to the characters and then join to a string, if they match the checksum, then we add the result. Then we get a sum of all the sectors that are valid. That was part 1. Part 2 is deciphering these guys by rotating each character by the number of the sector ID times. So for each word we go and split the word again. We don't care about anything after the square bracket open this time, and we just split it by minus. And the last one that we split it is the number. Split this away, that's the number, and then this is the rest. So we drop the last. And for each part, so each of those is one part, we decrypt it, which works in the way that we get the code of the character. A is code 97 and Z is the last number, 122, and everything in the middle is available. So B is 98 and so on. Then let's say we have A, we set the code minus 97, so A becomes 0. Then we add the number of n, which let's say is 402. Then we modulo it by 26, so it's between 0 and 25. And then we add 97 again. That way we were able to move it around the list between 97 and 122. So we even can add more numbers, and it will always lap around. And then we get the car again. So this goes into the code and this goes out of it. And then we just join the decoded characters to string and map that into our list of strings here, which we can join to string. You can join here as well. So we just have a string, a normal string, and a decrypted string. And then the question was, what sector ID of the room where North Pole objects are stored? So I just searched for North Pole and got the number. That's it.